Good day guys, I'm Nico from Exclusive Tutorials, and today we're going to be discussing JAMB PHYSICS physics, and we're going to be solving probable questions that will actually come out in the JAMB PHYSICS. Okay, today we're going to be looking at some questions. Let's start from this, a very simple question. Let's start from a very simple question, and the question says, what type of a physical quantity is electric current? What type of physical quantity is electric current? Okay, we have heard of scalar quantities and we have heard of vector quantities. Okay, we know that scalar quantities are those quantities that have only magnitude but no direction, while vector quantities are those quantities that have both magnitude and direction. Okay, electric current is a scalar quantity. Electric current is a scalar quantity. Electric current is a scalar quantity. So that is that for this question. Okay, the next question we're going to be taking is what is the value of the capacitance of a capacitor? What is the value of the capacitance of a capacitor of charge inertia and voltage 5 volts? Okay, what is the value of the capacitance of a capacitor of charge 9 coulombs and voltage 5 volts? Okay, we know that Q is related with capacitance and voltage by this formula, and they say what is the value of the capacitance of a capacitor of charge 9C? So Q is equals to 9C, while V is equals to 5V, and we know that since Q is equals to CV, then V will be equals to Q over C. C will be equals to Q over V. For this, we'll be making use of this formula. So C will be equals to 9 over 5 Faraday. 9 over 5 Faraday. That will be the answer to this question. Okay, the next question we're going to be taking. Next question says, what is the dimensional formula? What is the dimensional formula of capacitance of a capacitor? What is the dimensional formula for the capacitance of a capacitor? What is the dimensional formula for the capacitance of a capacitor? What is the dimensional formula for the capacitance of a capacitor? Okay, we must be very used to dimensions. Where we know that the major dimensions we have are the M, the L, and the T. Now, to find the dimension of stuff like this, we need to know our base formula. Okay, let's keep this formula in mind. Okay, let's say we have this formula, Q equals to CV. We're actually looking for the dimension of C. We're looking for the dimension of what? We're looking for the dimension of what? C. And we already know that Q is equals to IT, while V is equals to what? The voltage. So IT is equals to CB. But then we also need to simplify V. V is voltage or electromotive force. We can also simplify this V from this formula. W is equals to QV. This is work done. So from here, V is equals to what? W over what? Q. If you bring this V equals to W over Q into here, we have IT is equals to C times W over Q. So certainly we also know that this one is equals to IT too. So we have IT is equals to CW over IT. So in other words, we can cross multiply. Let's come this way. We can cross multiply, and we can say that IT square is equals to what? CW. In other words, we're looking for C. So C will be equals to IT square over W. Now remember that W is equals to force times distance. So C is equals to IT square all over force times what? Distance. You get? So now C will be equals to IT square. Let's simplify force times distance. Force is equals to mass times acceleration times distance, right? So we can still continue simplifying this. We can say C is equals to IT over mass. Acceleration is velocity over time times velocity over what? Time times what? Distance. We can continue simplifying it. The simplification goes further. We can go further to say C is equals to square. We can go and say C is equals to IT square all over mass times distance over time. This is for velocity, then times distance. This simplification goes further to say IT square all over mass times distance over time square times what? Distance. This simplification goes further to say. Now let's start presenting it in their dimensional form. Current in dimensional form will be ampere. Ampere square equals the square. Time remains T square all over mass remains M. Distance remains L. Distance remains what? L. Now this can go further to be A square T square over M. L times L is L square. L square. This 2 come up to be T what? Minus 2. This can go further to be M minus 1. L minus 2. T2 minus 2, because this minus 2 will come up. Then lastly we have what? A square is equals to M minus 1, L minus 2, T for A square. That should be the answer to the dimensional formula of capacitance. So we're done with this question. So the next question we're going to be taking is in a uniformly accelerated motion. In a uniformly accelerated motion, the speed varies from 0 to 20 meters per second in 4 seconds. The speed varies from 0 to 20 meters per second in 4 seconds. What is the average speed? During the motion? What is the average speed during the motion? Okay, yes, so that is the question. In a uniformly accelerated motion, the speed varies from 0 to 20 meters per second in 4 seconds. What is the average speed during the motion? Okay, now look at what they give us. in a uniformly accelerated motion, the speed varies from 0 to 20 in 4 seconds. The speed varies from 0 to 20 in 4 seconds. What they're asking us is that we should find the average speed. Now they gave us velocities. First of all, let's find our acceleration. Now you must know that there's a difference between average speed and average velocity. Average speed is equal to total distance over time, while average velocity is equal to total displacement over time. So first of all, here we are going to find our acceleration, right? So our acceleration is equal to changing this velocity over time, right? So acceleration will be equals to 20 minus 0 over 4. Acceleration will be equals to what? Acceleration will be equals to 5 meter per second square. Now we need to find the distance. Like, okay, what distance does this guy? What distance does this guy travel? What distance does he actually travel in? Does he actually travel in 4 seconds? We can use different formulas. We can use v square equals to u square plus 2as. Then we can also use s equals to ut plus 1 over 2at squared. Let's go with this one. Now say v square is equals to u square plus 2as, right? Now we can say 20 square is equals to 0 square plus 2 into 5 times s. So now what we can actually do is we can actually say now that 400 is equals to 10s. S is equals to 400 over 10. S is equals to what? 40 meter. Now we have gotten the total distance. Now to calculate the average speed, we can now say that average speed is equals to total distance over total time. Average speed is equals to 10 meter per second. Average speed is equals to 10 meter per second. Okay, let's take another sample question. Okay, let's say a body, a uniformly accelerated body moves from point A to point B. If an accelerated body moves from point A to point B in, let's say, t seconds. If the velocity at point A is 0 meter per second, okay, that means it actually started from rest, and the velocity at point B is 20 meter per second. Okay, velocity at point B is 20 meter per second. What would be the velocity midway? What will be the velocity midway between A and B? If you look at this question, a uniformly accelerated body moves from point A to point B in t seconds. If velocity at point A is 0 meter per second and velocity at point B is 20 meter per second, what will be the velocity midway between A and B? What will be the velocity midway between A and B? Now, there's a formula. There is a long cut, but there's also a shortcut formula we can use to solve this question. We can say the velocity midway. Okay, let's use P to say midway velocity will be equals to square root of u square plus b square all over 2. So this will be equals to square root of 0 plus 20 square. Okay, this is also square all over 2. This will be equals to square root of 400 over 2. This will be equals to square root of 200. Square root of 200. Now this is equals to 10 root 2 meter per second, or we can also say 14.14 meter per second. Can you calculate to verify? 14.14 meters. So this will be the answer to this question. So let's take another question. Let's take a question from projectile. So first of all, I'll be dropping some shortcut formulas of projectile. Now, in projectile, there's a relationship between height and range. Maximum height and range. We must have heard of this formula. Say h is equals to r root tan theta over 4. And there's a relationship between range and time of flight. The formula goes like this: time of flight is equals to square root of 2r tan theta all over what g. Now these are formulas that you might probably be new to. So let's take a question that we can use to buttress maybe one of these formulas. Let's take a question that we can use to buttress one of these formulas. Okay, let's take a question. Let's say we have a body is uniformly projected horizontally to an angle of 30 degrees. Okay, let's work with this. To an angle of 30 degrees. Let's work with 45 degrees to make things easier, since we're actually not working with a calculator. But just so you know, tan 30 is equals to what? 1 over root 3. Just know all this. Then tan 60 itself is equals to what? Root 3. Tan 45 is equals to 1. Then no sin 60 is equals to root 3 over 2 is equals to cos 30. Then sin 30 is equals to 1 over 2 is equals to cos 60, right? All these ones. Then sin 45 is equals to root 2 over 2 is equals to cos 45. We should know all these special angles. Okay, then let's take a question. Let's say if its maximum range is 10 meters. Calculate the total time of flight. Now, and the maximum height. Now, instead of actually coming to start using the projectile formulas, you can actually just say total time of flight is equals to square root of 2r tan theta all over j. Okay, take g is equals to 10. So we can say t is equals to square root of 2 times 10, 20 tan 45 over what? 10. Tan 45 is equals to 1. So t is equals to square root of 20 over 10. T is equals to root 2 seconds. T is equals to what? Root 2 seconds. Simple, clean, clear, sharp. Okay, now let's say we have to calculate the maximum height. Now the maximum height is equals to r tan theta over what? 4. Maximum height will be equals to 10 times tan 45 over 4. Tan 45 is 1, so that will be 10 divided by 4 will be 2.5 what? Meter. Clean and what? Clear. Okay, let's take another question. I'm going to be taking questions from a whole lot of topics. Let's take another question. Okay, let's say we have a question like this. The law of inertia. The law of inertia is called okay, I actually want you guys to attempt this before checking the answer. The law of inertia is also called, the answer is called the Newton's first law of motion. Newton's first law of what? Newton's first law of motion. This law actually states that a body will continue in a state of rest or uniform motion except interfered by an external force. Meaning, if you place a body on a table, or you just place a body moving at zero acceleration, right, with uniform velocity, moving at zero acceleration, the body can continue like that forever, or the body can stay at rest forever, except there's an application of an external force. An external force can move this body, or an external force can make this body to start accelerating. So that is the Newton's first law of motion. So the law of inertia is also called the Newton's first law of motion. Let's take another question. Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the force applied is proportional to the extension produced. So we have F is equals to K E. This is Newton's law. Provided the elastic limit of an elastic material is not exceeded, the force is directly proportional to the extension. The force applied is directly proportional to the extension. Let's say we have a problem like this. Let's say we have a block being pulled at an angle to the horizontal, let's say theta. A block being pulled at an angle to the horizontal, let's say theta. Then we have frictional force acting here. Then we have the normal force. Now, because the normal force is in this direction, let's say P, the force in the horizontal direction becomes P cos theta, while the force in the vertical direction becomes P sin theta. Now, the weight comes down, while the normal direction goes up. Now, we're going to be applying many formulas. Now, let's say for C, they said calculate the acceleration in dragging this block, let's say through a distance d. Calculate the acceleration in dragging this block through a distance d. Calculate the work done. Calculate the acceleration. Now there are different formulas you can use. Now we can say, remember, work done is equal to force times distance. But the part of force we are going to be using the horizontal components. So work done will be equal to P cos theta times distance. While if they say we calculate the acceleration, remember, from force minus frictional force will be equal to the net force, right? Equals to the net force. So now force minus frictional force will be equals to what? The net force is equal to the mass times the acceleration. Net force is equal to the mass times the acceleration. So we are going to have something like, therefore, we now have that the frictional force will be equal to the P cos theta. So force minus P cos theta will be equals to what? A. Now for this part, not when calculating the work done, for this part we work with the normal P So the normal P minus P cos theta is equal to what? MA. So we can say A is equals to P minus P cos theta all over M. You can also work with this. You can say P minus P cos theta all over what? M. You can simplify further. You can say A is equals to P 1 minus cos theta all over what? M. You can simplify further like this. You can also work also. So that is this for this. So you should also try and note this. Okay, now let's say we also have, we have a simple pendulum. Let's say 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 we have a simple pendulum. And it said calculate the energy. We're moving from this to here. So now the energy will be equals to mgl into 1 minus cos theta. Like L is in length. Now if you say calculate the velocity, equate this energy. If you can calculate the velocity, you can equate this energy to the kinetic energy. So now say 1 over 2 mv squared is equals to mgl 1 minus cos theta. We can equate this, we can cancel this out. So we now say v is equals to square root of 2gl 1 minus cos theta. That will be the velocity of the what? Pendulum in the what? Question. Okay. Let's take more questions. Let's take more questions and see what we can do here. Let's say convert a temperature of 300 Kelvin. Convert the temperature of 300 Kelvin to Fahrenheit. Convert the temperature of 300 Kelvin to what? Fahrenheit. Convert the temperature of 300 Kelvin to Fahrenheit. Now we know the relationship between F and C, that F is equal to 9 over 5 C plus 32. If I'm correct, yes. Now it's equal to 9 over 5 C plus 32. But they gave us the temperature in Kelvin, and we know that K is equal to C plus 273, right? K equals to C plus 273. So we know that C is equal to K minus 273, right? So we can just bring down here. So we can say F is equal to 9 over 5 into K minus 273 plus 32. Then this becomes F equals to 9 over 5 300 minus 273 plus 32. F is equals to 9 over 5 into 300 minus 273. 300 minus 273 will give us 27 plus 32. Use calculator to work it out. You get your final answer of 80.6 degree watts Fahrenheit. So that is that for that particular type of the question. Okay, let's take another question. Let's take another question. Okay. Sound waves can be polarized. Sound waves can be polarized, true or false. True or false. Now we know that polarization can only apply to what? Perpendicular wave, not longitudinal wave. And sound wave is a what? Longitudinal wave. So sound wave cannot be polarized. So the answer is what? False. Sound waves cannot be polarized. So the answer is false. Okay. Let's take another concept. Okay, let's say we must have seen this. Now let's say we have a pulley. A pulley system of a mass and they say calculate the acceleration. Let's say this is m1, m2. Let's say the direction of motion is like this, which means m2 is actually greater than what? M1, right? Okay, now they say calculate the what? Calculate the, let's say they ask us to calculate the force, or sorry, the acceleration on this pulley. Let's say to calculate the acceleration on this pulley. Now the acceleration is equals to the net force over what? The total what? Mass. So acceleration is equals to, the net force will be equals to m2g minus m1g over total mass will be equals to m2 plus what? m1. This will be the total force. This is the total acceleration acting on the what? Pulley. This will be total acceleration acting on the pulley. Now, per se they ask us to say calculate the tension. Calculate the tension in this system. How do we calculate the tension in this system? First of all, to calculate the tension in this system, we have to consider a lot of factors. Okay, this is actually not an HVAC glider. So let's say we're calculating the system, tension in the system normally. Now you see this M2 is going down. Why this is coming like this, right? This M2 is coming down. This M2 is coming down. Why this is coming like this? So how do we actually apply the concept of tension to this? We can actually say this M2G, that is the weight, M2G, the weight of this stuff, M2G minus, are we going to be minusing the tension, or we're going to be minusing the acceleration? So we're going to be minusing the tension. M2G minus the tension is equals to the what? M2A. So this is like, it will be like the net force is equals to the acceleration. So after getting acceleration, we can just say tension is equals to M2G minus what? M2A. You can work with this. After getting your acceleration is equals to M2 minus M1 or into G over M2 plus M1. You can just easily substitute the acceleration here and get the value of the what? Tension. Very easy, very clean, very clear. Okay, let's take another question. Okay, let's say we're taking a question from, let's say radioactivity. Let's say we are taking a question from radioactivity, and it said, okay, actually to me radioactivity is actually more of logic, and it said, okay, let's say I love using substance. A substance with a half-life. A substance with a half-life of n. Sorry, let me give you actual value of the half-life. Okay, let's say a substance with a half-life of 10 minutes. The substance has a half-life of 10 minutes. It has a half-life of 10 minutes. How many? Okay, how much of the material of the substance would remain after 40 minutes? Okay, now let's take this question. Let's take the substance to be equal to n, the initial substance to be equal to n. Now they actually said, okay, how much of the substance will remain after 40 minutes? And they said the half-life of the substance is equal to what? 10 minutes. Now you can go conventionally. That is, let's say the half-life of the substance is 10 minutes. Let's say after 0 we have n, after 10 we have n over 2, after 20 we have n over 4 after 30 etc after 40 dot. We're going to be solving it. I want to actually show you a method that we can actually use to solve it. Now, first of all, let's find the value. Let arrow is equals to 2 raised to the power n, not this. So now let's say then arrow be equals to 2 raised to the power the actual time over half left. Then arrow will be equals to 2 raised to the power 40 over what? 10. It will be equals to arrow is equals to 2 raised to the power 4 is equals to 16. Now if you observe something now, we can now say fraction remaining is equals to 1 over arrow. Please note this formula. After noting your arrow, fraction remaining is equals to 1 over arrow, so that fraction remaining will be equals to 1 over what? 16n. That is the initial substance remaining is n. So fraction remaining will be equals to 1 over 16. 1 over 16, or you can even move them. Fraction remaining because 1 over 16. So 1 over 16 of the material will remain after 1 over 16 of the material will remain after the 40 minutes. But now they say how much of the material will remain. So it's very simple and clear from here. If 1 over 16 of the material remains after the 40 minutes, then the amount of material that will remain will be equal to the fraction remaining times the initial amount of the material we started with. So that will be equal to 1 over 16 times n will be equal to n over 16. Okay, for just more cases, let me drop the formula. Now, just note these formulas. Fraction remaining plus fraction decayed is equals to what? 1. So fraction remaining is equals to 1 minus fraction what? Decayed. Or we can say fraction decayed is equals to 1 minus fraction remaining. And we have already said that the fraction remaining is equals to 1 over arrow. So fraction decayed will be equals to 1 minus 1 over what? Arrow, which will be equals to arrow into arrow minus what? 1. Now the amount remaining after half-life will be equals to amount remaining after the period of time will be equals to the fraction remaining times initial amount. Then the amount decayed will be equals to fraction decayed times what? Initial amount, where arrow is equals to 2 raised to the power n and n is equals to time all over half-life. So you note all these formulas from radioactivity. They can be quite helpful and very needful, very important too. Okay, let's take another question. Okay, let's say they ask this question. A block of, let's say a block of 10 kg is pushed across a horizontal rough surface. With coefficient of friction equals to 0.4. Coefficient of friction equals to 0.4 with a force of 10 Newton. The force of what? 10 Newton. Calculate its acceleration. Now we can simply go with this formula. F minus F arrow is equals to ma. We can go with this formula. We can say the force is 10 Newton. Frictional force is equals to U mg cos theta, courtesy of form U arrow. So we can say this is equals to, but since there is no theta, we can actually omit the theta and say this is equals to what? UMG, since we now have no application of theta here. So this will now be equals to minus 0.4. Okay, take G to be equals to 10. 0.4 into the mass is what? 10 kg times 10 times 10. 0.4 times 10, that is U, then M times 10 is equals to, the mass is what again? 0.4 times the acceleration. Now it becomes 10 minus 10 times 10 is 100. 100 times 0.4 is 40, is equal to 0.4 times A. Now note this, the moment the frictional force becomes larger than the normal force, the frictional force becomes larger than the normal force, acceleration becomes negative, or acceleration tends to be negative, or mathematically, the more F arrow tends to be greater than F, acceleration tends towards the negative sides. Acceleration tends towards the negative sides. So actually, natural sense, in O-level perspective, we can actually say there was no movement of the block at all. But let's say if there was actually movement, let's say the force is actually now greater than the frictional force. Let's say if we change this to 100 Newton, and let's say this becomes 100 Newton, then we can actually go further to solve. Then we can actually now say 60 is equals to 0.4 A is equals to 60 divided by 0.4 is equals to 60 times 10 over 4. This will go into this to give what, 15. If I'm very correct, then this will be 150 meter per second square. You can see the acceleration is very large. That is 150 meter per second square. The acceleration is very large. When the block was moving at 150 meter per second square, and it's actually possible. Okay, let's pick a question from JAMB past question itself. Okay, let's see, we have something like, let's say we have, which of the following causes dispersion? Which of the following causes dispersion? Which of the following causes dispersion? Let's say which of the following causes dispersion? Which of the following causes dispersion? Okay, they gave A, refraction, B, reflection, then C, total internal reflection. I just use this as an acronym. Then they gave D, total internal dispersion. Now, which of the following causes dispersion? The answer is A. Refraction is what is responsible for what? Dispersion. Because when you have, for example, let's say dispersion of light in a prism, when you have, let's say, light coming through a prism, then it actually comes to give you light of different wavelengths. That is actually dispersion. So refraction actually causes what? Dispersion. Refraction is what is responsible for dispersion. So this, I believe this question came out in JAMB, so please take note of the question. Okay, now let's take another question. Okay, see this typical question from radioactivity again. I said, what will happen in 7 hours? What will happen in 7 hours if a radioactive substance has a half-life of 7 hours? If a radioactive substance has a half-life of 7 hours. Okay, the answer to this question is very simple. This question is that half of the material will decay in 7 hours. If the substance has a half-life of 7 hours, half of the substance will decay. So that is answer to the question. Half of the substance will actually decay. So these and many more are the major things that you should know for JAMB. Okay, for JAMB, there are a lot of major topics. Let me drop some heat topics that actually come out in JAMB. You cannot JAMB will not miss this: electricity, magnetism, electromagnetism, AC circuits. In fact, the full SS3 work, just the full, if you pass your secondary school, your full senior secondary school 3 work, just make sure you know them. Then you know your sound waves, or generally just know everything about waves. Then you can brush through your mechanics and also heat. Certainly this combination of all these topics should give you more than 90% in your JAMB physics. To give you more than 90% in your JAMB physics. JAMB physics is very simple if actually read, because currently now JAMB sets thousands of questions across many of these topics, because it's CBT. The CBT will actually shuffle your set of questions and give to you. So you actually need to prepare from all round and come read everything again. JAMB is actually close, so start studying past questions and doing a lot of revision. My name is Zico, and that will be all for today on the tutorial.